equations, Algebra 1 EOI review. Systems of equations is Standard 2, Relations and Functions, Objective 4. Remember, relations and functions is our most highly tested standard, and systems of equations is part of that standard. If you look at how many questions or ideal number of items are going to be on the test over systems of equations, this says 4. So out of the 31, it's not the largest chunk, but systems of equations is still an important concept to know before you take this test. We have 3 different ways to solve systems of equations. The first is solving systems by graphing. To solve systems by graphing, you're going to graph both the lines in the same coordinate plane. The point where the lines intersect or cross is the solution. So if you look at this example, it says, what is the solution to this graph system of equations? They've kind of done all the hard work for us. We have 2 lines that are graphed in the same coordinate plane. And notice the point of intersection is going to be right here where I've placed that dot. And the ordered pair for that point is going to be 3, -2. So my answer is C. This next example says the graph shows 2 options to buy tickets for amusement park rides. Julia can pay $12 for a daily pass, or she can pay $1.50 per ride. So they've given us ticket options. They've told us the line that would be how much she would pay if she was paying per ride, and then also the daily pass cost. It says, for what number of rides is the cost of both options the same? So they're asking at which point on this graph are both options going to cost the same, and that's going to be this point where they intersect. Now this is only asking me for the number of rides. The number of rides is shown on the x-axis, so the corresponding x value for this point is going to be 8. So my answer is B. It's going to be $12 to ride 8 rides, regardless of how she pays. If she wanted to ride less than 8 rides, then it would be cheaper for her to pay the $1.50 per ride. But if she wanted to ride more than 8 rides, then it would be cheaper for her to get the daily pass. This says solving systems by substitution. When one or both equations are solved for one of the variables, substitute that expression in for the variable in the other equation. Solve for the remaining variable and then plug in that value to one of the original equations to solve for the other variable and get your ordered pair. To solve systems by elimination, you can add or subtract the 2 equations to eliminate one of the variables. Then go through the same process of solving for the remaining variable, then plugging it back in to one of the original equations to solve for the other variable. So when you're talking about systems of equations, you're going to have 2 different answers, an ordered pair with an x and a y combination. And so it's important to know both of those. Once you've solved for one variable, you're going to use the 2 original equations to plug in that value and solve for the remaining variable that's unsolved. This gives us a system of equation, and it says, what is the y value of the solution to this system of equations? They're only asking me for the y value right now. If you notice, both of these equations are solved for y. We have y equals x plus 2 and y equals -x plus 4. What we want to do is we want to keep our y value and somehow get rid of my x value. So if you look at these 2 equations, if we were to use the substitution method, we could, because both of these are solved for y, so we could just set them equal to each other. But that's going to leave me with my x variables left, and that's not really going to help me very much because they want me to find the y value. Now, I could find the x value and then plug it back into one of these equations. But I can also solve by elimination. When I add these 2 equations together, my x's are going to eliminate or cancel each other out. And I'm going to be left with just y's and constants. So remember to add, we have to line up our like terms and our equal sign, which is already done for us. So y plus y is 2y, equal, bring straight down the equal sign, and x plus negative x is going to be 0. They're going to cancel each other out, so I don't need to bring anything down there. And then 2 plus 4 is 6. If 2y equals 6, I need to divide both sides by 2, and I would get y equals 3. Now, if I wanted to solve for x, what I would do is I would choose one of my original equations, either y equals x plus 2 or y equals negative x plus 4, and I would plug in 3 for y and solve for x. This next example says, what is the x value of the solution of this system of equations? Now they want us to solve for x. To do that, I need to get rid of my y's and only have x variables left. The way that I'm going to do that for this equation is to use substitution. Even though one of these is not already does not already have a variable isolated, I can take this first equation, x plus y equals 4, and I can solve for y by subtracting x from both sides. When I do that, I get y equals negative x plus 4. You can also have 4 minus x. It doesn't matter. Now what I'm going to do is I'm going to take negative x plus 4, and I'm going to plug it in for y into the second equation that they gave me in the system. So I'm going to have 2x plus 3, parenthesis, negative x plus 4. That's where I've substituted in my expression for y, equals negative 2. The reason why I solved for y for the first equation is because by substituting negative x plus 4 in for y, I've eliminated my y's. My y's are no longer there, and I'm only left with x's. Because they want me to find the x value of the solution, that's going to be helpful. Go ahead and distribute your 3, and when you do so, you get 2x plus negative 3x plus 12 equals negative 2. Combine like terms, and you get negative x plus 12 equals negative 2. Subtract 12 from both sides, and you get negative x equals negative 14. Well, if negative x equals negative 14, then a positive x equals a positive 14. My answer is D. This next example says you have, Hannah has $11.20 in a jar that contains only nickels and dimes. There are 140 coins in the jar. How many dimes are in Hannah's jar? We have two pieces of information here. First of all, she only has nickels and dimes. We have two different values that those nickels and dimes add up to. The value of each nickel and dime adds up to $11.20. So I could write an equation, 0.10 times D. D is going to stand for dimes and N is going to stand for nickels, plus 0.05 N equals $11.20. Why I chose 0.10 for D is because each dime is 10 cents. And why I chose 0.05 for N is because each nickel is 5 cents. The second equation that I can write is that dimes and nickels, just how many there are all together, are going to add together to equal 140 because it says there are 140 coins in the jar. I can use any method that I would like to solve this system. I'm going to go ahead and use substitution by taking this second equation that I wrote, D plus N equals 140, and I'm going to go ahead and solve for N by subtracting D from both sides. The reason why I'm going to solve for N is because then I can get rid of the N's in my first equation and be left with only D, or dimes, since they want to know how many dimes are in Hannah's jar. So now I'm going to take N equals 140 minus D, and I'm going to plug in 140 minus D for N in the first equation, which is going to give me 0.10 D plus 0.05 times 140 minus D equals $11.20. Go ahead and distribute your 5/100ths, and you get 0.10 D plus 7 minus 5/100ths D equals 1120. Combine your like terms, And now it's just a two-step equation that I need to solve for D. I'm going to subtract 7 from both sides, and I get 0.05D equals 4.20. Divide both sides by 5/100, and you get D equals 84. So my answer here is D. This last example says Matt starts with $15 and saves $10 a week. At the same time, Julie starts with $45 and saves $5 a week. In how many weeks will they have the same amount of money? I'm going to use my variables here. I'm going to use T for total amount of money, and I'm going to use W for week. So if Matt starts with $15 and saves $10 a week, I'm going to say that T equals 10W, which would represent the $10 each week that he saves, plus the 15 that he starts with. For Julie, my equation is going to be T, or his total, equals 5W plus 45. Because both of these equations are equal to T, I can set the 10W plus 15 equal to the 5W plus 45. I've simply substituted and set them equal to each other because they're both equal to T. I need to solve for W now, and first thing I'm going to do is combine like terms. I'm going to start by subtracting 15 from both sides, and then I'm also going to subtract 5W from both sides. What that does is it gets my W's on one side and my constants on the other side. So I'm left with 5W equals 30. Divide both sides by 5, and you get W equals 6. So after 6 weeks, or C, they're going to have the same amount of money. Really quickly, we need to discuss no solution and infinite solutions for a system of equations. A system has no solution when the two lines are parallel, or they have the same slope and different y-intercept. So if you have two equations that have the same slope and different y-intercepts, you know that that system is going to have no solution because they're parallel and they're never going to intersect or have a point in common. Infinite solutions. A system has infinite solutions when the two lines are the same or have the same slope and same y-intercept. So if you're graphing a line on top of itself, every point on one line is going to be a point on the other line as well, which means you're going to have an infinite number of solutions.